Hello student, myself Antara Prasad, Assistant Professor of EC Department of Guru Nanak Institute of Technology. This is my lecture series on RF and Microwave Engineering and the code is EC701 and the course is under 7th semester of BTech course in Electronics and Communication Engineering Department. And here my contact number and mail IDs are given, and if you have any query then you can mail me. The course name is RF and Microwave Engineering and the course code is EC701 and the total lectures for this course are 34. Now there are some course objectives. There are four course objectives. First one is distinguish the RF and microwave spectrum, planar transmission lines, and high frequency circuit elements. And second course objective is determine the microwave passive components and scattering matrix representation. The third course objective is illustrate the microwave tubes, semiconductor microwave devices, justify the microwave application and a typical microwave test bench. These are the course objectives. Now there are some course outcome that after completion of this course, the students will be able to understand the microwave frequency range and their application. Also, they will be able to develop fundamental understanding of the two-port RF network and matching techniques. Also, they will be able to learn the scattering matrix for microwave passive components, understand the microwave tubes and devices along with their fundamental principle of operation. Also, they will be able to learn the microwave measurement techniques. Now, under module 2, there are different topics, that is high frequency circuit elements, difference in high frequency and relatively low frequency behavior of lamp circuit components, miniaturization and design of lamp components at high RF, and realization of reactive elements as waveguide and planar circuit components. And next is waveguide passive components and their S matrix representation in port networks. Properties of S matrix, transmission matrix and their relationship, microwave passive components and their S matrix representation. And under this, there are different type of passive components. In previous lectures, I have discussed about directional coupler with a hole coupler and attenuators and phase shifters. Now, today we will discuss about magic T, that is the micro passive components, and also we will discuss about S matrix representation of this magic T. Now, for that first we have to know what is waveguide T's. That waveguide T's are three-port components. Both are waveguide components. Waveguide components are three-port components. They are used to connect a branch or section of the waveguide in series or parallel with the main waveguide transmission line for providing means of splitting and also of combining power in a waveguide system. And the two basic types, that is E-plane, that is in series condition T, and H-plane T, that is the H-plane T, that is shunt T, are connected as shown in this figure. Now, these are named according to the axis of the side arm, that axis of this side arm which is parallel to the E field or the H field in the collinear arms. that is the collinear arm H field, and here at the collinear arm which are parallel to that E field. Now, because of the junction, waveguide T's are poorly matched devices. Now, adjustable matching reactances can be introduced by means of a tuning screw at the center. Because of symmetry and absence of nonlinear elements, they both have symmetry in structure. Because of this symmetry and absence of nonlinear elements in the junction, the S matrix is symmetric. That means if we represent that Sij like Sij, that is equal to S J I, and this I equal to 1, 2 and J equal to 1, 2, and the general S matrix for a T junction, that is here. Here in this is the S matrix, general S matrix for a T junction, that is S equal to S11, S12, S13, S12, S11, S23, S13, S23, S33. Next, we will discuss about what is E-plane T. Now, from consideration of symmetry and the phase relationship of the wave in each of the arms, it can be said that if a wave then is incident, if a wave incident at port 3, that is port 3, then it will result in waves at port 1 and port 2, and which are equal in magnitude but opposite in phase, that is S31 equal to S13 equal to minus S23, because opposite in phase, equal to minus 3 2, and S12 equal to S21. Now, if two in phase input waves are fed into ports 1 and 2 of the collinear arm, that's at the collinear arm, if the two in phase input waves are fed into this port 1 and port 2 of this collinear arm, the output waves at port 3 will be opposite in phase and subtractive. Now, sometimes this third port is called as difference arm, and by analogically with the voltage relationship in the series circuit, E-plane junction, the voltage relationship in the series circuit, and the E-plane junction is also called a series junction, that is the series junction, and all the diagonal elements of the S matrix of an E-plane T junction which cannot be zero simultaneously, since the T junction cannot be matched to all the three arms simultaneously. Now considering the port 3 is matched, the S matrix of a E-plane T can be derived as follows. Denoting that incident and outgoing signal variables in the ith port by AI and BI respectively for an input power at port 3. That port 3, the net power to port 3 is half within bracket mod of a3 square plus mod of minus mod of b3 square, that is equal to half a3 mod of a3 square into 1 minus s33 square, and the output power is half of mod of b1 square plus b2 square equal to mod of a3 square into s13 square. Since s31 equal to s32 by, as the matrix is symmetric, and for lossless junction the input power must be equal to the output power. That means half of a mod of a3 square into 1 minus s33 square, that is equal to mod of a3 square dot s13 square, or we can write that 1 minus mod of s33 square equal to 2s13 mod of s13 square, and by suitable matching elements we can make that s33 equal to 0, so that s13 equal to 1 by root 2, and from the symmetry characteristics which is described in above this part, from that we can write that s13 equal to s31, that is equal to 1 by root 2, and also s23 equal to s32 equal to minus 1 by root 2. And after matching port 3, if one attempts to match either port 1 or port 2, then by similar method the matching elements such as irises and tuning screws will interact with each other, and matching at port 3 would be disturbed since no port is isolated. Based on power consideration, it can also be shown that S11 equal to S22, that is equal to half, and also S12 equal to S21 equal to half, and for S33 when for when the condition is S33 equal to 0. Therefore, with matching at port 3, the S matrix of an E-plane T can be expressed by real values with proper choice of reference plane. That is mod of S, that S matrix equal to half half 1 by root 2, half half 1 by root 2, 1 by root 2 minus 1 by root 2 0, that is equal to, if we take common half, then half into 1 1 root 2 1 1 minus root 2 and root 2 minus root 2 0. Now if we consider the H plane T, that is H plane T. In H plane T, if two in-phase input waves are fed into port 1 and port 2 of the collinear arm, the output waves at port 3 will be in phase and additive. In case of E plane, that was subtractive, but in case of H plane T, it is additive, and because of this, the third port is called the sum arm. In this case, that was the difference, and here for H plane T, that is sum arm. Now conversely, an input wave at port 3 will be equally divided into in port 1 and port 2 in phase. because the magnetic field loops get divided into two arms, 1 and 2, in a manner similar to currents between branches in the parallel circuit or parallel circuit. And H plane junction is also called a, that's why an H plane junction is called as a shunt junction. And for a symmetrical and lossless junction, in absence of nonlinear elements at the H plane junction, the S parameter are obtained in a similar manner as in the case of E plane junction. And it is a, because it is a three-port junction, the scattering matrix can be divided as follows, that is matrix in order of 3 into 3. That's why S equal to S11 12 13, S21 22 23, 31 32 33. And if port 3 is perfectly matched in the junction, then S3 that is equal to 0. If port 3 is perfectly matched into the junction. And for symmetry also we can write that Sij equal to Sji. That means S12 equal to S12 equal to S21, S13 equal to S31, and S23 equal to S32, that is also equal to S13. Next is hybrid or magic T. Now a hybrid T that is formed with the combination of E plane and H plane T's, that is called a magic T, and it has four ports as shown in this figure. This is the one, port 2, port 3 and port 4. And this is the collinear arm 1, collinear arm 2, and that is the difference arm, that is or E arm, and that is the sum or H arm. Here the magic T has the following characteristics. When all the ports are terminated with a matched loads, let us consider the structure A with the ports as indicated. So if the two waves of equal magnitude and equal phase are fed into port 1 and port 2, here we are considering the figure A. Here, if the two waves of equal magnitude and equal phase are fed into ports 1 and 2, the output at port 3 is subtractive and becomes 0, and total output will appear additively at the port 4. Hence, port 3 is called as the difference arm or E arm, and the port 4, which and the total port 4 is the sum or H arm, and the wave incident, if a wave incident at port 3, that is on E arm, that divides equally between port 1 and port 2, but in opposite phase, with and with no coupling at port 4, that is the H arm. Thus we can write that S 1 3 equal to minus of S2 3 and S4 3 equal to 0. And next is if a wave incident at port 4 that divides equally between port 1 and port 2 in phase with no coupling at port 3, that is ER. Then we can write that S14 equal to S41 equal to 1 by root 2, that is equal to S24 equal to S42, and because there is no coupling we have to port 3, that's why S34 equal to 0. And next is if a wave fell into one collinear port, either 1 or 2, that will not appear in the other collinear port, that is or if or port 2 or port 1, and hence the two collinear ports, that is 1 and 2, are isolated from each other, and that will be that S12 equal to S21 equal to 0. Now a magic key can be matched by putting tuning screws suitably in the E and H arm without destroying the symmetry of the junction. Therefore, for an ideal lossless magic T which is matched at port 3 and 4, then S33 equal to S44 equal to 0. And the procedure of derivation of the S matrix considers the symmetry property at the junction, for which S14 equal to S41 equal to S24 equal to S42, and S31 equal to S13, that is equal to minus S23, that is equal to minus 32, and S34 equal to S43, that is equal to 0, and S12 equal to S21, that is also equal to 0. Therefore, the S matrix for a magic T which is matched at port 3 and 4, which is that is equal to is 11, is 12, is 13, is 14, and is 12 is 22 minus is 13 is 14, and is because here is 21 instead of is 21, we can write that is 12 and is 22, and instead of is 23 we can write is 1 3 minus is 1 3, because is 1 3 equal to minus is 2 3. Then if we in the replace of is 2 3, we can write that minus is 1 3 and is 2 4 equal to is 1 4. And next is 1 3 minus is 1 3 0 0, because and is 1 4 is 1 4 0 0. Now from the unitary property which is applied to rows 1 and 2, we get that a mod of s 1 1 square plus mod of s 1 2 square plus mod of s 1 3 square plus mod of s 1 4 square equal to 1, and mod of s 1 2 square plus s 2 2 square plus is mod of is 1 3 square plus mod of is 1 4 square equal to 1. And subtracting these two equations, we can get that mod of is 1 1 square minus is 2 2 square equal to 0, or mod of is 1 1 equal to is 2 2. And from the unitary property applied as at rows 3 and 4, we can write 2 mod of S13 square equal to 1 or S13 equal to 1 by root 2, and mod of 2 mod of S14 square equal to 1 or mod of S14 equal to 1 by root 2. And substituting these values into these two equations, we can write S11 square plus mod of S12 square plus half equal to 1, and finally S11 mod of S11 square plus S12 square equal to 0, and which is valid if S11 equal to S12 equal to 0. Now, from the above equation, that this equation this minus this equal to 0, and finally this, and from the equation of where which is valid, that S11 equal to S12 equal to 0, we can write that S22 equal to 0. Therefore, the matrix is equal to 0 0 S13 S13 0 0 minus S13 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 minus S13 0 0 S13 S13 0 0, where that mod of S13 equal to 1 by root 2 equal to mod of S14, and by proper choice of reference planes in arms 3 and 4, it is possible to make that S13 and S14 is real, resulting in the final form of S matrix of magic T, that is this, that is equal to 1 by root 2 0 0 1 1 0 0 minus 1 1 1 minus 1 0 0 1 1 0 0. And for the structure of figure B, for this structure, where the ports 3 and 4 are interchanged, that 3 and 4 here, that is the 3 port 3 and that is port 4. Here the ports 3 and 4 are interchanged, and if interchange occur, then the S matrix will be S equal to 1 by root 2 0 0 1 1 0 0 1 minus 1 1 1 0 0 1 minus 1 0 0. Now that's all for today, and in next class we will discuss about another passive components, wave-like passive component, that is circulator. Thank you.